All right, so here we are on class activity number 2 for 3.7 and 3.8, linear modeling. All right, so linear means lines, as we've talked about before, and modeling, pretty much it's going to be a word problem. All right, so we're given this problem. Given the following table, I remember we're talking about these kinds of tables, from the U.S. Census Bureau for the population of Texas. We have a table, and it says T stands for the number of years after 2000. Okay, so this is T. So the number of years after 2000, 0 years after 2000 would be still 2000. 1 year after 2000 would be 2001. 2 years after 2000 would be 2002. Yep, correct. All right. And then it says P of T. So remember, P of T, it's talking about a function. P of T is another name for Y. All right, so P of T is Texas's population in millions. So let's go ahead and read this table off again. So 0 years after 2000 is 2000. So in the year 2000, the population was 20.85 million. Okay, take a second and try to figure out what these two mean. Okay, so in the year 2001, the population in Texas was 21.28 million. And what does this pair mean? In the year 2002, the population was 21.71 million. All right, so what are we going to do with this? We have 5 parts. All right, so here we go. Part A. Find the average rate of change. Average rate of change, or remember, another name for that was the slope for this equation. Or sorry, for this modeling problem. Okay, go ahead and pause the video and try to see if you can find the average rate of change, otherwise known as slope. All right, so remember, if this is a linear equation, it does not matter which 2 points I choose to put together to find the slope. If I choose to put these 2 points together, the slope will be the exact same number as if I chose to put these two numbers together. So I'm going to go ahead and pick 0 and 1. Why? Because they're smaller numbers. Okay, so we will use the points 0, 20.85 and 1, 21.28. Remember, if you chose to use this point, you're still going to get the same answer. All right, so let's go ahead and how do we find slope when we were given 2 coordinate points? Well, remember we're going to use that equation. M equals y1 minus y2 all over x1 minus x2. So go ahead and pause the video and try to see if you can plug in the values and get the slope. All right, so let's go ahead and plug in those values. So to do that, I'm going to go ahead and label my subs. So x sub 1, y sub 1, x sub 2, y sub 2. You're probably going to need a calculator for this, so I'm going to be pulling out my calculator in a second. So y sub 1 is 20.85 minus y sub 2, 21.28. Ooh, I should be putting these in parentheses. All right, all over x1, 0, minus x2, 1. All right, so let's go ahead and plug that into our calculator and see what we get. Okay, clear your calculator. All right, so we have 20.85 minus 21.28. And we get negative 0.43. And 0 minus 1, I know that one, that's minus 1. All right. So negative divided by negative is a positive. And then any number over 1 is just itself. So this is actually going to be 0.43. Okay, so to write my answer neatly, I'll just write m equals 0.43. Remember, lowercase m is what we use to indicate slope. And there we go. Okay, part A is done. Part B. Find the Y-intercept. Okay, go ahead, pause the video, try to see if you can find the Y-intercept. All right, so remember the y-intercept. How do we find the y-intercept? Well, the y-intercept is when x equals 0. Okay, well, when is x 0? Okay, so remember, this is a modeling problem, so we're not using generic x and y. But if we look at this table, the generic values for t is the x values, and p of t is the y values. Okay, generically, it's x and y, but for this problem, we're calling x t, and we're calling p of t y. So, when is x 0? Well, it's this coordinate set right there. So, our y-intercept is going to be the y value, which is 20.85. So, our y-intercept is the point 0, 20.85. Okay, so the thing we did was we just looked at this table and found where x was 0, and that's the coordinate set for our y-intercept. Okay, so let's go for part B. I'm going to shift this up a little. Part C. Write an equation for p of t. Okay, go ahead and try pause the video and see if you can do this. All right, so an equation for p of t. So there are basically only two equations we know of. Let me shift this upwards. Two equations we know for lines. There is the equation, well, actually at this point we only know one equation for a line. And that equation is the one we looked at in the previous video, y equals mx plus b. Now remember, y, another name for y, is p of t. So rewriting this for our problem, we have p of t equals mx plus b. All right, so to fill out this equation, I need my slope and my y-intercept. B is the other name for the y-intercept. Alrighty, so do I have my slope? Well, yes I do. I found it right there, 0.43. Okay, so we're going to go ahead and replace the slope m with 0.43. And then what do I need for this equation? Well, I need b, my y-intercept. Did I find that? Yes, I did, right there. 20.85. Yeah, so taking that out, 20.85. And so, let's rewrite this neatly. My equation p of t equals 0.43x plus 20.85. And that is the equation, for Texas's population in millions. Okay, 2 parts to go. Let me go ahead and put some blank paper here so we can keep working on this and looking at our table. Actually, I don't think we need our table. Let's shift this up. All right, part A, B, C, D next. Okay. Part D, estimate. Estimate. Texas's population, Texas's pop in 2007. So I might be tempted to go to the table and look for the number 7, but notice this only goes up to 2. Shucks. So it'd be so wonderful if I had an equation so I could estimate the population of Texas. And well, what do you know? We actually found that equation right up here. Let me go ahead and highlight that because that's a beautiful equation. Hopefully without smearing anything. Kind of smeared. Oh well. Okay. So, I want to find out Texas's population in 2007. So, with our equation here, real quick. Remember, we're not using x, so actually I wrote this a little incorrectly. This should be P of t equals 0.43 t, because in our problem, we're not using the generic x. Sorry about that. And I went ahead and already highlighted it. Okay. Let's highlight the good one. This is the one we want to look at. So notice the only thing I changed was that we really should be using the variable t, not x. X is generic, and we're not using that for this problem. Okay, so we're using this equation to estimate the population. Okay, so Texas's population, remember, P of t was Texas's population, and t was the years since 2000. So what we want to do is we want to find P of t when t equals, okay, so remember, t is, let's take a look at this. T is the number of years after 2000. Okay, after 2000. So in the problem we're looking at 2007. So how many years after 2000 is 2007? Take a moment and think on that. Yep. So when t equals 7, because that's 7 years after 2000. All right, so how do we solve this? Well, what we're going to do, we're going to take out t, and wherever we see t, we're going to replace it with 7. Okay, so plugging in 7, P of 7 equals 0.43 times. Instead of t, we're replacing it with 7. We're evaluating for 7, plus 20.85. All right, so let's go ahead and calculate this. Pull out your calculator. Okay, let's see, 0.43 times 7. 0.43 times 7 is 3.01. Let's write that down. Plus 20.85. So let's add that. Plus 20.85 equals 23.86. Alrighty, and there we go. So to figure out what the population for Texas was in 2007, we went ahead and put 7 in replacement of t. So we plugged that in, and then we went ahead and simplified, and we found out that P of 7, so the population of Texas in 2007 is estimated to be, or was since that's in the past, is estimated to be 23.86 million. Pretty big. All right, okay, that was part D. Now we have one more part for this video. Let me go ahead and flip, I can't flip that over, I gotta get a new paper. Okay, part E. Let's just shift this up all the way. When will Texas's population double the population from 2000? Okay, so take a second and pause this video and try to see how you would figure this out. All right, so I'm going to bring back my table and we'll take a look at this. Okay, so what is this question asking? This wants to know when Texas's population will be double the population from 2000. So what are we trying to do? We're trying to find t, number of years after 2000, for when the population of Texas is twice the amount it was in 2000. So what's the amount it was in 2000? Well, let's look at our table. The amount in 2000 was 20.85. So we want to know when it's going to be twice 20.85. Okay, so twice that, or doubling it, we're going to times 20.85 by 2. Okay, what is 20.85 times 2? I do not know. 2 times 20.85, 41.7. Okay, so we're trying to find t when p of t is 41.7. Okay, so how do we find this? Well, we're going to go back to that equation we've been using, the one that we worked so hard to create. Right there. That beautiful equation from part C. Okay, so let's use our equation. Let's use our equation. P of t equals 0.43t plus 20.85. All right. How are we going to use this? Well, we're going to take away p of t and replace it with the number 41.7. So where do we see p of t in this equation? Right here. So take that out, replace it with 41.7, and let's evaluate this. So shifting up. All right, so evaluate 41.7 equals 0.43t plus 20.85. Okay, remember, we're trying to find t. So where is t? Goodness. I'm looking at this equation. T is right there. Okay, so I'm going to try solve for t. So how do we get t by itself? Well, let's subtract the 20.85 from both sides. We're trying to isolate t. And once again, I do not know what that is. So let's pull out our calculator. 41.7 minus 20.85 is 20.85. Huh. Well, I should have known that. That was double. It will. 20.85 equals 0.43t. All right, so solving for t. T is almost by itself. Let's divide by 0.43. Okay, so 20.85, divide that by, what is that? 0.43. We get, a nice long decimal. So remember, what I've said in this class is, unless I tell you otherwise, just round to the hundredths place. So let's see that. That's the tenths, and there's the hundredths at the 8. Looking to that side, 8 is bigger than 5, so we're going to round up. So our round up answer will be 48.49 is approximately the t value. What does that mean? Well, let's go back to what our table talks about. T is the number of years after 2000. So if t is about 48.49, well, it's kind of weird to talk about years in terms of decimals. So for the sake of this problem, let's just look at t is approximately 48. Okay, because remember, we're just estimating, so unless I tell you otherwise, as long as you estimate and it sounds correct in terms of the problem, we can go with it. All right, so 48 years after 2000, what would that be? 2048. So the population of Texas will double when? Well, 48 years after 2000. Will double in the year 2048. Alrighty, so for linear modeling, we create an equation a lot of the times, and then from that equation, we'll go ahead and plug in random values to find different meanings. Alrighty.